Hi all of you, welcome to the part 2 of the math session. The part 1 was number systems 1 and today we have set up 5 more questions in the form of number systems 2. The idea is just to explore the commonly used questions in the CAT series. Last time we had a theme, this time it's not a complete theme set, but again I assembled the questions of 2018, 19, 23, 24 randomly and made a set of 5 questions. So this is the first question of the series of 5 questions. We are solving the first question. It says n and x are positive integers and there's a condition given to it such that n raised to n is 2 raised to 160. Now that's interesting. That forces us to take a pause to find out the value of n. Once we get that, it's almost done. After that, there's a condition n square plus 2 raised to n should be made as an integral multiple of 2 raised to x. You need to read it twice, but not very difficult to understand. In that case, what can be the maximum possible value of x, right? So as I told you initially, the challenge is how can n be found out? N raised to n, we are given it is equal to what? 2 raised to 160. Now, if you break 160 in the form of prime factors, so 160 is 2 into 80, 80 is 2 into 40, 40 is 2 into 20, 2 into 10, and 2 into 5. So we have got 5 2's and we've got 1 5. This itself gives a very big clue because we have to have n as the base and n as the index. So the idea is if we write this as 5 into 2 raised to 5 and then using the basic laws of indices, if we write it as 2 raised to 5 raised to 2 raised to 5, you simply get the value of n as 2 raised to 5 and that's 32. Nice. So if we have found out n as 32, now the next point is n square plus 2 raised to n is an integral multiple of 2 raised to x. So I'm simply substituting the value of n, that's 32 square plus 2 raised to 32. 32 can be written as 2 raised to 5, that's further raised to 2 plus 2 raised to 32. So I can write this as 2 raised to 10 plus 2 raised to 32. And just simplifying it to the extent possible so that I can get on to the actual question. I don't think I can do anything more than that. If at all I can do anything, I can take 2 raised to 10 common. What am I left with? 1 plus 2 raised to 22. Done. So the question is 2 raised to n. So which is, n square plus 2 raised to n, this number should be an integral multiple of 2 raised to x, right? This should be an integral multiple of 2 raised to x. Now, this is a subset of 2 raised to x. 2 raised to x is bigger than this. We know 2 raised to x is even number by all means. And this is a product of even and this is odd. The bracket is odd. 1 plus even number is always odd. So that goes to say that 2 raised to x can only take the form of 2 raised to 10, and that allows us to prove that the maximum possible value of x that we can have is 10, and hence the answer is x being 10. So nice question, a laws of indices based question, and then some orientation towards the end after the simplification happens takes you to the answer. Let's see the next. Very old question. What's the remainder when this is divided by this? I guess even CAT 2010 students know this family of question. But since it appeared in CAT 2024 also, we teachers are not, we are not ready to call it as outdated question. So it deserves an attention. What is the remainder? People call it as modulus theorem or remainder theorem. It is based on that. This is divided by this. So instead of doing going on with the modulus theorem, I'm solving it with the Euler's theorem. So for that, what you need to know is this is the numerator. I'm just rewriting this. This is the other part of the numerator, and this is the denominator. If the divisor, that is 25, is a co-prime number with 13 and with 17. That's condition number 1. And if you can find the Euler's number of 25, and if you can find that number here, the remainder is 1. What I mean to say is, the Euler's number of 25 is to be found out first. And how do we find that out? The prime factor of 25 is just 5. So every fourth number is not a multiple of 5, right? So 20 is the Euler's number of this, right? There are 20 numbers that are co-prime with 25, right? So let me just check the numbers that are not 1, 5, 10, 15 and 25. So all is well. So now, if I can express the power of 13 as a multiple of 20, which actually is, then the remainder is 1. So this is a multiple of 20. So I can straight away write the remainder as 1. I found out the Euler number of 25, which is 20, and I'm trying to find out whether the power of 13 is multiple of 20. It is indeed. Even in this case, 100 is a multiple of 20. Needless to say, I checked this. 17 should be a co-prime with 25, which is. So finally, 1 plus 1, the remainder is 2, and that's my answer. So that's how you use the Euler's theorem in this case. Third, number of integers x such that 0.25 is smaller than 2 raised to x and 200 is more than 2 raised to x, and 2 raised to x plus 2 is perfectly divisible by either 3 or 4 or both. Okay, condition is noted. So 0.25, which can be written as 1 by 4, and we need to find out the possible values that x can take. 1 by 4 is 2 raised to minus 2. A number more than that is 2 raised to minus 1 or 0 or 1 or 2 or 3. 2 raised to 4 is 16. I'm just simultaneously checking whether it's lesser than 200 or it's crossing 200. 2 raised to 5 is 32. 2 raised to 6 is 64. 2 raised to 7 is 128. 2 raised to 8 is 256. I need to stop at this. So x can take all these values, but there's something more. 2 raised to x plus 2 is perfectly divisible by 3 or 4 or both. So if I take 2 raised to minus 1, that's half, plus 2, this won't be divisible because it's not integral. So this is out. 2 raised to 0 plus 2, that's 3. It's divisible by 3. 2 raised to 1 plus 2, that's 2 and 2, 4. That's divisible by 4. 2 raised to 2, that's 4 and 2 plus 6, that's divisible by 3. 2 raised to 3, 8 plus 2, 10. That's not divisible by 3. It's not even divisible by 4. 2 raised to 4 plus 2, that's 18, is divisible by 3. 2 raised to 5, that's 32 plus 2, 34. It isn't. Then 2 raised to 6 plus 2, that's 64 into 66 is divisible. 2 raised to 7, that's 128 plus 2, that's 130. It's neither divisible by 2 nor by 3. 2 raised to 8 is beyond the reach. So the numbers that we have is this is 1, this is 2, this is 3, this is 4 and this is 5. So there are 5 such numbers as per the requisites the question presented, perfectly divisible by 3 or by 4, and that's your answer. The quantity is 5. Moving on to the fourth question. A factorial question in number system is almost mandatory. 15 factorial is expressed in the form of base 8. What is the last non-zero number? By last non-zero number, for example, 32,000. These are zeros and this is non-zero. So 2 is the last non-zero number. That's what the question wants. Okay. So now let me just get on to the question. 15 factorial, and I'm looking out for 8. Let's first find out the number of 2's in 15 factorial. 15 divided by 2, that's 7. 7 divided by 2, that's 3. Quotient. 3 divided by 2, that's 1. 7 and 3, 10 and 1, 11. So we've got 11 2's in 15 factorial. but our interest lies in the 8s. So 2 raised to 11 can be written as 2 raised to 3. 3 threes are 9 into 2 raised to 2. 9 into 11, right? Now there are 3 8s. This is 8 cube into 2 raised to 2. So any appearance of 8, if you get into the base of 8, you will see a 0. For example, the number 8 has got 1 0. 64 has got 2 zeros. And 512 in the base system 8 will have 3 zeros. So we straight away have got 3 zeros here, and that is into 4. So that's apparently 4000. So the last non-zero number will be 4. And that's our answer. So the last non-zero number is 4, because here it's going to finish with the number of zeros, and 4 is smaller than 8. You can't reduce it. That acts as the remainder itself. So 4 will stay, and 4 acts as the last non-zero number, right? How's the last fifth question? Look simple. How many pairs of m and n of positive integers satisfy the equation of the form m square plus 105 is n square? Quite conventional again, but quite a few questions are these days based on the identities of n square, n square. Some experts say it's a part of algebra. When it has to do a lot with the number game, it's a lot of arithmetic. So I wrote in the number system because it's less with the formation of equation or playing with too many equations, but it's to play with the numbers and combinations of numbers. So that's why it forms its appearance in number system. So this can be written as n square minus m square is 105. So n minus m into n plus m is 105. And how do you write 105 in integral form? It can be 1 into 105, then 3 into 35, 5 2s are 5 1s are 5 and 21. 6 is not going to be there. 7 1s are 7 15s are. That's it. So the numbers are 1, 2, 3, 4. How many pairs? There are 4 pairs. And the answer is 4 for this. So that is a set of simple 5 questions. Not simple, but conventional. And these inputs that we discussed here really can find a place in one of the exams, CAT, XAT, and the similar exams that you are going to take. So I chose these 5 questions to revise. Just to confirm. Okay. So that's it, guys. I'll stop here. Thanks. See you with the next PPT. I'll come up with Algebra 1 with one set of family in it. Bye.